This is my private network. Just a minute. Yes. So guys, this is my private network and this one is the public network, internet. And by default, private and public cannot communicate with each other. Even internet public network is not going to allow any private IP address. That private IP addresses are not routable on the internet. This is why we are saying it is a reusable, because internet don't know any private IP address. What private IP address you are using inside the organization, that is completely unknown from the public network. How public network knows your organization? With the help of public IP address, which ISP is going to provide you over here on the WAN link. You can have one public IP address as well, and you can have a pool of public IP address as well. So we come up with NAT, network address translation, to reduce the shortage of IPv4 address. To reduce the shortage of IPv4 address, right? So we divide IPv4 address into two parts, into private and public. Private and the public. So what is the difference between private and public? First difference is it is reusable. Private IP address is reusable, means I can also use 10.1.1.0 and you can also use 10.1.1.0/24. Guys, my private IP address is 192.160.1.6 and lakhs of people are using this IP address, right? But still I am able to access internet. So the reason, NATing, translation. So first we divide IPv4 address into private and public, and then we come up with NAT technology, right, to translate the private into public and public into private, right? So it is reusable, it is free. Sometimes we are saying it is a temporary IP address as well. And public IP address is, guys, payable, right? Not reusable, right? And routable on the internet. Internet means you can reach to internet with the help of public IP address. right? And the private IP address is not routable on the internet, right? So if I am using, let's say, this PC, on this PC if I am defining a public IP address 100.1.1.1, then NAT is not required. The reason, this PC have already public IP address which is reachable on, which is routable on the internet. So this PC can reach to internet with the help of their IP address. But if here I am using private IP address 10.1.1.1, then translation is required, because on the internet router there will be ACL which will be blocking all private IP addresses. Only public IP addresses are allowed on the internet router, right? So before forwarding the packet to internet, router 1 have to translate it. Router 1 have to translate it. Otherwise, guys, let's say 10.1 want to ping 8.8.8. What will happen? It will forward traffic to router. Router 1 will compare the destination IP address with their routing table. This is a default behavior of router to forward the traffic, right? Whenever router will receive a traffic, how it will treat the traffic? First it will check destination MAC. If destination MAC will match or destination MAC is broadcast, then it will check layer 3 information, and in layer 3 information it is going to check the destination IP address. It will compare destination IP address with the routing table. If destination IP address is router itself, then it is going to check upper information, right? Upper layer information. If the destination IP address is the IP address of other devices, then it will compare destination IP address with their routing table, right? And it will find the next hop IP address, or you can say the exit interface, and it will forward the traffic. But this time, as router 1 is edge router, as this router is edge router, first these routers have to translate the source. So on all the edge routers we are going to configure NAT so that it will perform translation. Now if NAT is enabled on router number 1, then before checking the routing table, router 1 is going to perform translation, right? So this is one interview question. Router will look up first NAT table or first routing table. So router will look up first NAT table. Got it, guys? Okay, so why translation is required? If let's say 10.1 want to ping 8.8.8, source IP 10.1, destination IP 8.8, it will forward to router. On the router, route is not available, so let's say I have configured one default route. Default route means if a specific route is not available in the router, then router will use default route, right? 0.0.0 means all the route, right? For all the route, let's say exit interface is f1/0, right? So this default route means except all the route available in routing table, except those all routes which are available in routing table, you will forward traffic towards internet. For all the rest routes, means this is gateway of last resort. If route is not available in the routing table, then I need to forward traffic to internet router. Now I have configured the default route. So what will happen? This time router will forward traffic to internet router. Internet router is going to compare the destination, right? 8.8.8 is destination. So 8.8.8 is router itself. So it will generate the reply message. In the reply, source IP 8.8.8, destination IP 10.1. Will route available on the internet router, guys, for the private IP? No. So router 1 is going to drop the packet. What I am saying, if without translation, if router 1 will forward traffic to internet, then what will happen? Source IP 10.1.1.1, destination IP 8.8.8.8, it will forward to router, router will forward to internet. Internet router is going to generate reply where source is 8.8.8 and destination is 10.1.1.1, and we cannot configure route, right, on the internet router for private subnet. So now internet router don't have route for this destination IP address, so it will drop the traffic. The other thing that NAT offer you is it can hide your IP address. You know, NAT is not only to translate private IP address into public IP address or public IP address into private IP address. NAT can translate private to private as well and public to public as well, right? Like if you want to hide your IP address, let's say this is my server and I want to hide the IP address, actual IP address of my server for the security reason. So I can use NAT. I can even configure dual NAT. One for the all employees should be able to access internet, one to hide the IP address. And guys, inside the network, in the internal network, we can have multiple departments. Yes. As I told you, NAT can translate private to private also, na? Brother, let's say the IP address of this machine is 10.1.1.2. So for one translation I am translating first this IP address into 20.1.1.1 and then I am translating it to 100.1.1.1 like this. Okay. So if someone asks you why we come up with NAT, so answer is to reduce the shortage of IPv4 address. How we reduce the shortage? By dividing IPv4 address into private and public. What is the benefit? Benefit is private IP address is reusable, right? Multiple organizations can use same private IP addresses and the public IP address is routable on the internet. So one organization can be represented on the internet with the help of single public IP address, right? And guys, inside the company I can have multiple building, multiple subnets, multiple departments, again the same thing. And we can translate all the departments IP address into a single public IP address as well, or in a pool of public IP address. So we have multiple types of NAT translation. We'll see those all one by one. Okay, the basic concept is clear, guys. Why we come up with NAT and what is NAT. Even don't worry about what is NAT, because we are going to learn what is NAT only today. Why is clear? Why we come up with NAT? Any question in this? You can say NAT is an technology which is used to make communication possible between private and public network. By default, private and public cannot communicate with each other. As I told you, the reason on the public network there is no route available for the private IP. Even private IP addresses are not allowed on the internet, right? So by default, private and public cannot communicate with each other. So that's why we come up with a technology called NAT. And which is the private network? Private means your inside network, your organization network, and this is public network, right? So guys, the IP addresses which I will use over here will be public, right? And the IP addresses which you will use over here is private, right? From the each class we have a range of IP address for private and a range of IP address for the public, right? This is the range. This is a range of private IP addresses. Except this range, all the IP addresses from each class are public IP addresses. Right, guys? So from class E, inside the organization, I can use IP addresses from 10.0.0.0 to 10.255.255.255. How many IP addresses are there? 2 to the power 24. Right? From class B, this is the range 172.16.0.0. So whenever you will check IP address of your laptop, you will see IP from these range only, right? And from the class C, guys, 192.168.0.02, 192.168.255.255. How many IP addresses are there? 2 to the power 16. Right? So that's why even you can see the IP address of my laptop. This is a private IP address, IP config. Right? And if you want to see my public IP address, here I can say what is my IP address. You can see this is the IPv6 address and this is IPv4 address, right? So this is the public IP address. This is my public IP address. So my home router is actually what is doing, what is translating my private IP address into this public IP address. On the internet, guys, whenever I am searching anything on the internet, I am reaching to internet with the help of this public IP address only. Yeah. No, no, bro, it is not secure. Okay. So I am reaching to internet with the help of this public IP address. Now, guys, how NAT works. So see what will happen here. Let's say here I have one router. Then I have one switch. Then internet. And after that, here I have some PCs. R1, switch 1, and the internet. Right, guys, on the ISP there can be multiple servers. Like this, right? These are the services on internet, right? And like this, on the internet there are million of servers. So can I configure route for all the service on router 1 on my edge router? No. So the first thing is here I have to define one default route, right? Means 0.0.0/0 towards ISP, towards internet. Because it is not possible to configure route for all the services on internet on router number 1. If it is possible, let's say you have limitation that my company should only access this network 100.1.1.0/24, then you can configure the route. Then you don't need to configure the default route. But if you want to allow all the traffic to internet, then you have to configure default route only, right? The next thing, this is my guys private network. This is my private network. So here the subnet I will use is private. Let's say I'm using 192.168.10.0/24, right? And here you are going to purchase public IP from ISP. So let's say your public IP address is 1.1.1.0/30, means you have two public IP address. One you are going to configure on your side and one on ISP side. So let's say dot 1 is your IP address and dot 2 is the IP address of ISP, right? This PC have IP 192.168.10.1, correct? Now what NAT will do here? See, when PC1 will try to access 8.8.8 or 100.1.1.1, 192.168.10.1, and destination is, let's say, 8.8.8.8. This is the packet PC have generated. Now this PC is going to forward it to router R1. By default, if NAT is not running, then router 1 will check the routing table. It will compare destination IP address with routing table, right? It will match in default routes and it will forward towards ISP. ISP is going to drop it. The reason, route is not available for this source IP address, so ISP cannot generate reply. Now you are going to configure NAT here. So configuring NAT means I'm going to tell to my router 1, bro, whenever you will receive this packet, do one thing, translate source IP address, which is 192.168.10.1, into the public IP address which is running on your interface 1.1.1, and then forward traffic to ISP. And when you will get reply, that time again translate destination 1.1.1 to 192.168.10.1, right? So what this router will do, once this router will receive this traffic, it will translate source IP address. Source means 192.168.10.1 to 1.1.1.1, the public IP address. So guys, on the router number 1, what will be the source IP address in packet, in the new packet? 1.1.1.1, and destination will be still same 8.8.8, right? Then router 1 is going to forward it to internet. So this time internet is receiving traffic from 1.1.1, which is the public IP address, which is routable on the internet. So ISP router will have a route for 1.1.1, correct? So ISP can generate reply. So this time ISP will generate reply. In the reply, source IP will be 8.8.8.8 and destination IP will be 1.1.1.1, right? ISP will forward it to router 1, and router 1 is maintaining a table that I have translated 1.1.1.1, sorry, 192.168.10.1 into 1.1.1.1. So when it will receive reply, at the time of reply it will translate destination. At the time of request, router will translate source. At the time of reply, it will translate destination, right? So source will be same 8.8.8 and destination will become what? Source 8.8.8 and destination will become this time 192.168.10.1, right? This is how NAT works. But how router will get to know that whenever I will receive traffic on this interface, then I need to perform translation. So guys, there are some terminology of NAT. So let's understand some terminology. First one is inside. This inside and outside, is it clear to all? Inside means my private network. Inside means my network. And outside means the public network, right? So here in this scenario, I can say this is my inside, this is inside, and this is outside. Inside, outside. Inside means your private network, outside means your public network, right? So first terminology is inside local. Second is inside global. Global. Third one is outside global, and fourth one is outside global, and fourth one is outside local. Outside local. See, like your private network, this is your private network. In the same way, Google will also have what? Same private network. Google will also have same private network, right? There they will have lots of servers, and their network is connected with internet, right? These are the public IP address. Let's take one example of a company like Google. These are the public IP address. This can be public IP address of a private company, right? Let's say there is one network of Google. Router, router, then switch, and then they can have servers, right? This is what the private network of Google. They will be also using what? Private subnet inside the network. Their private subnet is 10.1.1.0/24, and these are the public IP address. These are the public IP address of Google, right? So let's say if you want to access this server of Google 10.1.1.1, you will hit to the public IP address. You will access to the public IP address. There will be one-to-one translation. There are many types of translation. We will discuss that, right? I2. So this is network of Google. This one, yeah. Yes. See, inside local means my local network. This one, fine. Inside global means my public network. This one, right? Outside global means the Google public network. This one. And outside local means the Google private network. This one. right? So to access the server of Google, I cannot access Google server with the help of private IP address. With the help of private IP address which Google is using, I can access Google server with the help of public IP address. And in that scenario, one-to-one NAT is required. So these are what, guys? These are terminology, means you can say one kind of domain, right? Areas in the NAT, right? So first, the in the inside local, whatever interface is connected with inside local, that interface must be configured as inside. That interface must be configured as inside. And whenever router will receive traffic on inside interface, it will come to know I need to translate source. Getting my point? Router will come to know I need to translate source IP address. And the interface which is connected with inside global, interface which is connected with inside global must be configured as outside, right? So we are going to configure this interface as outside. And once router 1 will receive traffic on outside interface, it will get to know I need to translate destination. So whenever router 1 will receive traffic on inside interface, it will translate source, means this IP address. Whenever it will receive traffic on outside interface, it will translate destination, this IP address. In the same way, Google, see, this is the inside network, so they are going to configure this interface as inside interface and this interface as outside interface. Clear, guys? Okay, so let me do one thing here. Between router 1 and internet, I'm going to use any public IP address. Let's say 1.1.1 0/30. For now I'm using /30, but see, I can have a pool of public IP addresses as well. So either I can purchase /30 or /29 /24, right? You can purchase a pool of public IP addresses as well, a single public IP address as well. So let me access the internet, and first of all I'm going to configure the internet router. Hostname internet, and I'm going to create one loopback here for 8.8.8 interface loopback 1 IP address 8.8.8 255.255.255.0. Then interface F0/0, which is the WAN port, no cert, and IP address here 1.1.1.2 to 255.255.252. Submit mask for /30 and exit. That's it. Only IP address we are going to configure on the internet router, right? And we can block the private IP addresses on fast Ethernet 0/0, right? How we can block the private IP address over here? I can create one ACL, and in that ACL I will only allow this subnet 1.1.1.0/30. Rest all are denied. So here I can say access list number 10 permit, let's say 1.1.1.0 0.0. What will be the wildcard mask? 3. Wildcard mask, right? So we are only allowing 1.1.1.1 and 1.1.1.2 over here. Rest all IP addresses are denied. Yeah. if anyone have issue with the access control list, don't worry for now, right? We are not talking about the ACL. See, today we are going to use ACL just to match the traffic. Like my internal subnet is 10.1.0.0/16, right? So how I will tell to router that bro, you need to translate IP address from this subnet. For that I am going to use ACL to match the subnet. So I have configured the internet router. Now let me access my edge router R1, and on R1 I need to configure two interface, F0/0 and F1/0. Interface config T, host name R1, and then interface F1/0, say no set, and IP address 1.1.1.1.255.255.255.252. Now guys, can I ping internet? Do ping internet router 1.1.2? Yes, I can ping to internet router. See, success rate is 80%, now 100%. I'm able to ping internet router. Only these two IP addresses are allowed on the internet router. So can I ping from my LAN interface from 0/0? No, I cannot ping 8.8.8 from this interface. Here let's say subnet is 10.1.1.254, or last IP address 255.254, 255.255.255.0, right? Or I can configure NAT for, let's say, building 1. I am configuring NAT, so 1.254.255.255.255.0, right? On the switch, by the way, I can create multiple VLAN, and then on router I can create multiple sub interface, and I can configure NAT on that sub interface as well. Now guys, ping 8.8.8. Can I ping 8.8.8? Will ping work? No. Why? No, 8.8.8. If I am pinging 8.8.8, so it will ping from this interface only, now F1/0. So this is the public IP address. Where is the private and public? No, I am directly pinging 8.8.8 from WAN interface. Let's say source interface fast Ethernet 1/0. Okay, on the internet I am going to allow 8.8.8 as well. Let me do one thing. Let me allow permit 8.8.8. Actually, you know how we are going to configure ACL on the internet router? We'll be blocking all the private IP addresses. We'll be allowing only the public IP address from each class, right? So for now 8.8.8.8 is also allowed over here. The reason why I'm not able to ping 8.8.8 is route, right? Once you will ping 8.8.8, it will check the routing table, right? So IP route, and route is not available. Even gateway of last resort is not set, means default route is not there, so router 1 will drop the traffic. So let me create one default route here, IP route 0.0.0, 0.0.0. I'm saying exit interface F1/0 and next hop IP 1.1.2. Now can I ping 8.8.8? Will work? 100% this time ping should work, and you can see ping is working, right? The reason why ping is working, guys, because it is pinging from the WAN port, right? Source IP address is 1.1.1.1. Source IP is 1.1.1.1. That's why ping is working. But I cannot ping this IP address from the LAN port fast Ethernet 0/0, right? Still router 1 is forwarding traffic to 8.8.8. Yes, bro. Because of default route, so IP route. See now, this default route is reachable from 1.1.1.2, and exit interface is fast Ethernet 1/0. So source will be what? Exit interface. Source IP will be the IP address which is running on exit interface. Correct. Correct. Fast Ethernet. No, one rod cannot have, same rod cannot have on two interfaces, na bro? How router can have same route on two interface? If same route is available on two interface, then it will perform load balancing. Whenever I am pinging any IP address from here, it will check their routing table, right? And source will be, guys, the exit interface IP address. Source will be the exit interface IP address, right? Or manually I can define here that source should be fast Ethernet 0/0. Then it will put source IP address which is running on fast Ethernet 0/0. By default, source WAN interface 1.1.1.1, right? So if I am saying source fast Ethernet 0/0, then ping is not working. Still router 1 is forwarding traffic to internet, right? To verify it, we can do one thing. We can debug ICMP on internet router, debug IP ICMP, right? And let's try to ping again. See, this router, internet router, is getting, it's generating the reply message, right? Where source is 8.8.8 and destination is 10.1.1.254. The reason why it is dropping the traffic, route is not available for this IP address. This is the source. This is the private, right? So IP route. On the internet router, we don't have any route available for this IP address, right? That's why internet router is dropping the traffic. Correct? So we can apply it over here, interface F0/0 0/0 IP access group number 10 direction. It was just for example, brother, right? Like ISP is going to configure the ACL on their interfaces to deny the all private IP addresses. We are not using the ACL over here. No, so ACL is allowing 10.1. Okay, ACL is also denying this private IP address. Yeah, but I didn't apply the ACL. This is the, see, first of all, ACL, guys, again, when ACL will check after the routing table. ACL will check after routing table. First route is not there in the internet router. That's why it is dropping the traffic. Yes. First NAT, then routing. Correct. They are reverse. Correct. Done. So what we need to do here, before forwarding traffic to the internet, we need to translate the source, right? Source should be here what, guys? 1.1.1.1, right? The public IP address. Right? So the first thing is, see, for now I am just removing the ACL from here. Otherwise it will make confuse to some people. No IP access group number 10 direction in. I have removed the ACL, right? And still you can see ping is not working, right? So it is not like because of ACL we are getting packet loss, packet drop, no. Route is not available on the internet router. So to configure NAT, first of all we need to define inside and outside interface, right? So interface F0/0, this interface is inside, so I will say IP NAT inside, right? Then interface F1/0 IP NAT outside, right? I have tell to my router which is your inside interface, which is your outside interface. Now I'm going to tell to router, bro, whenever you will receive traffic from this subnet 10.1.1.0/24, that time you need to perform translation. So how to make the interesting traffic, how to define the traffic subnet with the help of ACL. So access control list number 10 and say permit 10.1.1.0 while karma 0.0.255. With the help of this access control list, I am only defining this subnet, guys. That's it. There's no any other use of this ACL. Even I can use route map instead of ACL. I can use prefix list to identify the traffic. I want to identify the source subnet which is going to be translated, right? So that's why here I am using ACL. Fine. Now I'm going to enable NAT. So IP NAT inside source, and from where it will match the source, it will find source from list number 10. From the access list number 10 it will find the source IP address. So IP NAT inside means NAT the traffic on inside interface from the source list number 10, and in the list number 10 we have this subnet 10.1.1.0/24, and after that I am saying translate it into the IP address which is running on interface F1/0. Translate into the IP address which is running on fast Ethernet 1/0. And we have multiple types of NAT, right? One is PAT. So to enable PAT I can run this command overload, right? Now guys, if I will try to ping 8.8.8, ping 8.8.8 and source fast Ethernet 0/0, you can see ping is working. This time ping is working. Correct? And so IP NAT translation, here you can see the 10.1.254 is the IP address on my LAN interface, translated into this IP address inside global, inside, yeah, okay, inside local IP address is 10.1.1.254, inside global IP address is 1.1.1.1, and outside local and outside global is 8.8.8, right? Guys, actually this is port translation, right? PAT, this is a PAT, port address translation. Even you can see here on the internet router, when I am pinging 8.8.8 from router 1, see, internet router is replying to 1.1.1.1, not to 10.1.1.254. So let's say this PC have one IP address, IP 10.1.1.1/24, and 10.1.1.254 is the gateway, right? And now ping 8.8.8.8, and you can see ping is working. That means my end devices and users are able to access internet, and see internet is getting ICMP packet from this source 1.1.1.1, means my router 1 is translating. So IP NAT translation, then 10.1 is translated into 1.1.1.1. So in this scenario, all the IP address, all the private IP address will be translated into a single public IP address with the help of port translation. It is actually assigning the port number. Right. So now the next thing is types of NAT. Yeah, it is using random port number. In ICMP packet, we will not have any port number, correct? Because ICMP is a layer 3 protocol. So it will use any random port number, one for source, one for destination. Static NAT, second one is dynamic NAT, and third one is PAT, guys, port address translation. Nowadays we are using a static NAT and we are using PAT, but we are not using dynamic NAT, right? Understand all one by one. First of all, a static NAT, it is an one to one translation. Means one private IP address will be translated into one public IP address, or you can say one public IP address will be translated into one private IP address. Then the dynamic NAT. In dynamic NAT, guys, one subnet means group of IP address. Subnet means group of IP addresses. It is, you can say, one to many translation. Means many IP address can be translated into many public IP address. And the PAT is many to one translation. Means many IP address can be translated into single IP address. So guys, in this scenario, if I will configure a static NAT, how many public IP addresses are required? If I have 3 PC, then I need three public IP addresses, right? But as you know, in real time we can have lots of PCs, 1000 number of PCs. So can I purchase 1000 number of public IP addresses? No. Then where we are going to use a static NAT? Guys, we use a static NAT to provide access of our server to outside user, to the internet. Let's say I have a server and you want to perform lab on my server from the internet, right? So I need to configure one-to-one NAT. I need to configure one-to-one NAT, right? One-to-one NAT is required whenever we need to provide access to our internal server to outside user, to the user on the internet, right? So let's say here is some user on the internet, 100.1.1.1. User on internet means the user public IP address, like the my public IP address. In the same way, you are using one private IP address and internet know you with the help of your public IP address, right? So with the help of your public IP address, you can access to my server. Let's say this is my server where IP address is 10.1.1.10. So what I want, that outside users should be able to access my server. Then I have to configure what? Static NAT over here. Means one-to-one NATing. One-to-one NATing is a permanent NATing. I can configure 10.1.1.10 should be always translated into 1.1.1.1, right? So whenever router 1 will receive traffic over here, right, where destination is 1.1.1.1, it will directly translate into this IP address, then it will forward to switch. If router 1 is receiving a traffic on this interface where destination is guys, see outside, this is the outside user. If this outside user is going to access my server, right, source IP will be 100.1.1.1, destination IP will be 1.1.1, not 10. That is a private IP address. So this outside user will access my server with the help of public IP address 1.1.1.1, right? So it will hit on 1.1.1, it will forward traffic to router 1, and there is one-to-one translation, means permanent translation, that 1.1.1.1 will be always translated into this IP address. So router is going to translate 1.1.1 into this, and then it will forward to PC. Source IP will be what? No, 1.1.1 is public IP address. No, it will translate, router will translate 1.1.1 into 10.1.1.1. Right? So whenever you want to provide access to your internal server, then you have to configure one-to-one netting. Where we are going to use the dynamic netting, see guys, in one-to-one netting, I cannot use one-to-one netting for all the general employees so that they can access internet, because here we need lots of public IP address then. So we come up with dynamic net. In dynamic net, what will happen? We can purchase a pool of public IP address from the ISP. Right? Let's say I have purchased this submit 1.1.0/29. So how many IP addresses are there? How many IP addresses are there, guys? 6. Right? So one I am going to use on router, on the internet router, let's say .1, one over here .2, and I can create a pool of 4 public IP address 1.1.1.32, 1.1.1.6. 7 is the broadcast and 0 is the first IP address. Right? So when router 1 will receive request of PC1, it will translate source into the first IP address in the pool. For the second PC, it will use second IP address. For the third PC, it will use third IP address. Right? But if there is one more PC, PC number 4, and if PC4 will also try to access internet at the same time, then router 1 cannot perform translation. The reason? There is no free public IP address available in the pool. There is no free public IP address available in the pool. That means how many user can access internet at a time? Only 3. Only 3 user can access internet at a time. If you have 5 number of public IP addresses in the pool, that means 5 user can access internet at a time. So that's why dynamic net failed, guys. We come up with PAT, port address translation. Means all the users can access internet with the help of single public IP address. Right? In the PAT, routers are going to assign the port number. Right? Let's say 10.1 want to access 8.8.8. Right? So when router will receive the traffic, source IP will be 10.1, destination IP 8.8.8.8. Right? It is going to translate 10.1 into 1.1, and it is going to assign one port number, let's say P1, P2, and then it will forward request to the internet. When internet will generate reply, source will be 8.8.8, destination will be 1.1.1.1, source port P1, right? It will generate reply and it will send to router number 1. Now router 1 will receive the traffic, and again it is going to translate 1.1.1 into 10.1 by checking this table, right? So at the same time, if this PC will also try to access internet, it will use same public IP address 1.1.1, but it will use different port number, right? Port number for PC2 is 3, for PC3 is 4, for next PC 5, right? So at the same time, this router can send multiple requests with the help of same public IP address. In the every packet it is using 1.1.1, the translated IP, right? And with the help of port number it can retranslate, right? In the reply it can again translate public into private, right? So if port number is in the reply, if the destination port number is port 1, then I need to translate public IP address into 10.1. If port number is destination port is P3, then I need to translate it into 10.2. If port number is 4, then I need to translate into 10.3, like that. Like this it can perform translation. This is port translation, PAT. In the PAT many IP address can be translated. Even you can say all IP address can be translated into a single public IP address. So guys, here I have configured what PAT, and let me do one thing. Here I am going to use one more router, R2, one IOL device switch. And let's say this is another company, right? Or you guys at your home with the internet connectivity. Mm-mm. Done. And I need one PC as well. Here let's say I have one server. Let's say this is your left side is your home network, and this is my server, right? So this is my private network, guys. Here also I am going to use NAT. Either I can configure PAT or dynamic NAT, but here I have one server and I want to provide access to this server to outside users. So I am going to configure here a static NAT. Let's say my server IP address is 192.168.10.1, right? And between ISP and router 2 I am using 2.2.2.0/30, 2.2.2.0/30. Yeah, correct, correct. Done. Two private networks are there now. So let me configure another interface of ISP router first. Config T interface F1/0 no cert and IP address 2.2.2.2.255.255.255.252. Right, again I am going to save the configuration, right? Router 2 R2 interface F0/0 no cert and IP address 2.2.2.2, sorry 1, and the IP address 255.255.255.252, and then interface F0/0, my local interface F1/0, no cert, and IP address I'm going to use last IP address from the subnet 192.168.10.254.255.255.255.0. Done. See here, I have some another PCs as well, like whose IP address is 10.2, 10.3, 10.4, 10.5. So I need to configure two NAT here, right? One for all the general employees so that they can access internet, and one for my server, right? The static 1-to-1 NAT, so that you guys, means these user can access my server. So for the general employees, for all the user can access internet, I can configure what? Either I can configure dynamic net or I can configure what? PAT. So to configure dynamic net, what I will do, I will create one pool. So IP DHCP, sorry, IP NAT, and then I am saying pool this time. After that, name of pool is, let's say, Cisco, and after that the starting IP address in the pool, let's say my first IP address is 2.2.2.1, and the last IP address in the pool is, let's say, 2.2.2.6, right? And then net mask, or you can configure prefix length 29 like this. So I have created one pool. In the pool, guys, I have defined a range of public IP address. Now make sure this IP address is reserved for your organization. You have to purchase these all IP address from ISP. Until and unless you will not purchase this IP address from the ISP, what will happen, guys? There will be no route available. This IP address will be not reachable from your internet router, right? Then I'm saying IP NAT inside, and this time I'm saying source, again source from list, or list and route map option is there, right? Either I can use route map or I can use list. List means access list number 10, and then pool, right? So IP NAT means translate the inside from this source, from source list 10. In the list 10 I am going to define the subnet, this subnet, and I am saying translate into the IP address which is available in pool. In the which pool? In pool Cisco. That's it. Got it? This is what dynamic NAT. So it will translate IP address from the list number 10 into the range of IP address which is available in this pool. And now access list number 10, permit 192.168.10.0 wildcard mask 0.0.255. Done. Now outside user can access internet, like from this server you can try. Enable config t host name server and interface f0/0 no set and IP address 192.168.10.1 exit no IP routing and IP default gateway 192.168.10.254. Now ping 8.8.8.8. Why I'm not able to ping? The default route. Default route is not available on R2, so router 2 is dropping the traffic. IP route 0.0.0, 0.0.0 and 2.2.2.2. Right? Do ping 8.8.8.8. See, ping is working. Can I ping from the source LAN interface? Fast Ethernet 1/0. Set. Why ping is not working, guys? Because I didn't define the inside and outside interface. So let me define the inside and outside interface as well. Interface f0/0 IPNAT outside and interface f1/0 IPNAT inside. Now do ping 8.8.8 from this source and see ping is working. Means now server can also ping to internet. Just wait, let me troubleshoot what happened. So IP interface brief 192.168.10.1 correct. So run section gateway IP address is 254. Let me ping the gateway. Ping 192.168.10.254 and ping 8.8.8. I'm not able to ping 8.8.8. Here I am getting some error message. See guys, in the pool, what happened? In the pool I have defined 6 IP address, right? But I'm using /29 over here, /30 over here. So we have only 2 IP address and both are in used. I'm using one IP address on this interface and one IP address on internet router. So let me do one thing. Let me say no IP NAT pool Cisco, and it is in use, so you cannot remove the pool. So first of all you have to remove the NAT command. So do so run section NAT. I'm going to remove the NAT configuration first. This one, pool Cisco can't be deleted, no IP. Pool Cisco in use, can't delete, no IP NAT inside source pool, source list 10 and pool Cisco. Dynamic mapping, actually it is NAT is running, that's why we are not able to even delete the entry. What I can do, interface f1/0 no IP NAT inside, and now let me try to remove the entry. Do clear IP NAT. Done. Do so run section net. So now IPNet pool Cisco. So I am going to remove this pool command as well. And interface f1/0 is my inside interface IPNet inside. Now see, first I am going to change the subnet here. I am going to use /29 /29. So on the internet router also I have to change the subnet mask. Interface f1/0 IP address I am saying 2.2.2.2 and 255.255.255 dot. What will be the subnet mask for /29? 248. Save the configuration. Let me take you to R2 now. And on interface f0/0 here I am going to change the IP 2.2.2.1 255.255.248. Sorry, IP address 2.2.2.1 255.255.255.248. Now IP NAT pool Cisco, and this time in the pool I am going to define IP from 2.2.2.3 to 2.2.2.6. Right, these are unused IP addresses, and then say prefix list 29, no problem. Then IP NAT inside source match source from list number 10 and translate it into the IP address which is available in pool. In which pool? In pool Cisco. Got it? Now from the server, let me try to ping 8.8.8, and this time you can see ping is working. So like this server, all user can access internet with IP address from this subnet 192.168.10.0. Right? On router number 1, I am running PAT, port address translation, means all the private IP address will be translated into a single public IP address. And on router number 2, I am running dynamic NAT, means all the IP address will be, all the private IP addresses will be translated into a range of public IP addresses. Now guys, I want to provide access to this server to outside user. Outside user means to these PCs. So what we can do, here on router number 2 I can configure a static NAT 1 to 1 NAT. So on router number 2, IP NAT inside source static, right? Then define the inside local IP address. IP address of your server is what? 192.168.10.1, and then the public IP address inside global IP address. Inside global IP address is 2.2.2.1, right? That means this IP address, this IP 2.2.2.1 will be always translated into this private IP address. That's it, right? Before running this command, see, this IP address means when you will ping to this IP address means you are pinging to router. But after running this command, if you will ping this IP address from anywhere on the internet, you will access this server, right? So to verify it from PC1, I am going to ping this IP address, ping 2.2.2.1. See, I am able to ping. I am pinging to router 2 or server, guys. I am pinging to router 2. How to verify? Here I can enable the debugging. Debug IP ICMP. I am pinging to router number 2. Correct. Now let me configure the static net. What error was there? IPNet none static entry already exists. Do clear IPNet translation star. Done. Now this time if I am pinging 2.2.2, so tell me I am pinging to router or server? See, this time you are not pinging first of all router. Here you are not able to see any ICMP packet, right? But you can debug, enable the debugging on server. Debug IP ICMP, and let me try to ping again this public IP address. See, server is replying, right? That means I am not hitting this public IP address. Now I am hitting the server, right? Now I am accessing this server with the help of this public IP address, right? So this public IP address is reserved for my server. Means anyone from the internet can access my server with the help of this public IP address. With the help of this public IP address. Because whenever router 2 will receive traffic on this interface where destination on F0/0, where destination is 2.2.2.2, it will translate into this private IP address. You can verify the NAT table on router 2, so IP NAT translation. This is the static entry. Got it, guys? Yeah. Here is the output. I configure NAT inside on F1/0. One for the general users and one for the server, so that outside user can access my server. So yes, two NAT is running here. So run section NAT. Done, guys. This NAT is for this server, so that outside user can access my server. And this NAT rule is for all the employees in my network who can access the internet, right? Like here I have some PCs. So these PCs should be able to access internet. So how these PCs will access internet? With the help of this NAT rule, right? No, see, on this interface you need to run IPNet outside only once, and over here IPNet inside. On this outside, here inside, only once. Correct. No, bro, a static net is bidirectional. A static net is bidirectional. Means this private IP address will be always translated into 2.2.2.1, and 2.2.2.1 will be always translated into 192.168.10.1. It is bidirectional. A static net is bidirectional NAT. And everything is working fine, right? You can see from this network, PC1 is able to ping this server with the help of public IP address, as well as PC1 can access internet. Ping 8.8.8.8, able to access internet. They can ping to PC2 also. They can communicate with any device inside the network, and server can also access internet. Ping 8.8.8.8 it, right? And the other user in this network can also access internet. Got it, guys? Single public IP, yes, we can use. Even if I have multiple servers here, I can use multiple public IP addresses. One public IP address cannot be used for multiple servers. In that scenario, you have to configure then PAT, not a static NAT. And if you are configuring PAT, then outside user cannot access your server. If you want outside users should be able to access your server, then you have to configure one-to-one NAT only. And in one-to-one NAT, you have to reserve one private IP address for one public IP address. Any other question? Yeah. 100 users should be able to access the server. So static NAT, whenever you want to provide access to server, you are going to use static NAT only, bidirectional NAT only, because dynamic NAT and PAT is unidirectional, guys. Means inside user can access internet, but outside user cannot access the internal server. To access internal server, we have only one-to-one NAT, that is static NAT, which is bidirectional. Means inside user can also access outside network, and outside user can also access inside network. On router 2, yeah, on router 2 I am running two NAT. One is a static NAT, another one is dynamic NAT. Dynamic NAT for rest users except the server, and for server I am using a static NAT. You can access the internet, but internet cannot access you. Means unidirectional. Bidirectional means you can access the internet and internet can also access you. Like internet can also ping the server. From the internet, I can ping to server and it will work. Ping 2.2.2.1. See, ping is working. I am able to ping the server. But can I ping this PC? PC1? No. Because this PC1 don't have any public IP address, correct? So this is bidirectional NAT. Means server is also able to access internet and internet is also able to access this server. This is bidirectional NAT. PC is able to access internet, but internet is not able to access PC. This is unidirectional NAT. Any other question? Yeah, PAT is unidirectional, dynamic NAT is also unidirectional. Port forwarding means PAT. Yeah, same concept. Only router is going to assign one port number. One port to source, one port to destination. Because router is going to use same public IP address, right, for all the internal IP addresses. So they will use port number. It will assign one random port number. Let's say PC1. Yeah, go ahead, go ahead. I already told you we are not using dynamic NAT nowadays. We are using PAT and static NAT. No, Where I have assigned the port number? For port forwarding purpose means? PC to server. Yeah. Okay. No, I don't have idea about it. So in the PAT, what will happen? Let's say PC1 10.1 is trying to access 8.8.8. Router 1 will translate 10.1 into 1.1.1.1 and destination is going to be same. So it will assign one port number here. Let's say P1 and destination 8.8.8 to port number 2, P2, right? At the same time, PC2 is also trying to access 8.8.8. So source IP 10.2, destination 8.8.8, and it will translate source into 1.1.1.1. It will set port number 3 and destination 8.8.8.8. Port number is P4. Now let's say it is receiving reply from the internet, right? So guys, in the reply, if this source port is P2 and destination port is P1, it will get to know I need to translate public IP address into this private IP address 10.1, and then it will forward to switch. If in the port, if in the source port is, in the packet source port is P3 and destination port is, sorry, source port is P4 and destination port is P3, it will get to know I need to translate public into this private IP address 10.2, then it will forward to switch. So with the help of port number, it will identify the reply packet, because in the reply every time destination will be what, 1.1.1.1. So it will check the port number, destination port number. On the basis of it, on the basis of port number, it will came to know about the private IP address. What private IP address I need to translate. Done. Clear guys? Any question till here? How much? Like it depends on the ISP. In India, one one static public IP, and again it depends on the connection, right? Like you are purchasing dedicated link like MPLS link or the broadband link. In the broadband link, if you are purchasing one static IP address, it is going to cost you around $2 to $3 per month. This is a cost of public IP address in India for the broadband, not for the dedicated link, for the shared link. Now, okay, so we have understood how to make communication between private to public. Now guys, can these two private subnet communicate with each other? This is the private, this is the private. Both are connected together with the help of public network. Now how to make communication possible between two private network, right? So can these two private communicate by default? Definitely no, because see here IP is 10.1, here IP is 192.168.10.1. So if PC1 will ping to this server, this private IP address, what will happen? Source 10.1.1.1, destination 192.168.10.1. it will forward to switch will forward it to router. Router is going to check the routing table, right? In the routing table, route is not available for this networks, it will match in the default route, it will forward traffic to internet. Maybe if NAT is running, then it will translate the source, it will translate source to 1.1.1.1. Destination is still what? Private. So internet router is going to drop it. Correct? So two private network cannot communicate with each other through public network, right? The technology which we are using to make it possible is VPN, right? So now what we are going to do, we are going to configure VPN between router 1 and router 2. VPN is virtual private network. Virtual private network. So guys, through the public network we are going to create VPN. You know, first thing is VPN is an overlay network. Overlay network, right? And this physical network is your underlay network, right? Means over this physical network you are going to create one virtual network. That virtual network is overlay network. Actually what we need on router number 1, see, we need one another path to forward traffic to this network. Like I want whenever router receive a traffic for this network for 192.168.10.0/24 network, there should be one another interface. It should not forward traffic to internet directly. Like there should be one route. If there is one route, let's say for this network, and the exit interface is any interface, then it will not use default route, right? And if IPNet outside is not running on that interface, then even it will not perform the translation. It will not translate the source. So guys, to create the VPN between router 1 and router 2, we are going to create one virtual interface over here, that is tunnel interface. That is tunnel interface. On both router we will create one tunnel interface. Now how these two tunnel interface can communicate with each other, see, try to understand, it is very important. Here I have one public IP address, here I have one public IP address. Both public IP addresses are reachable with each other, correct? Both public IP addresses are reachable with each other. So whenever PC1 will generate traffic for this IP address, let's say source 10.1.1.1, destination 192.168.10.1, what if router 1 will add one extra header with this actual information, and in the extra header it is going to put this IP address as a source and this IP address as a destination. Source 1.1.1.1 and destination 2.2.2.1. Now can internet forward this traffic? Is it routable on internet? Yes, because source and destination both are public, right? So router 1 will forward it to internet router. Internet router is going to check outer header. Outer header, in the outer header destination IP is 2.2.2.1. Router, internet router will compare it with their routing table and then it will forward from here. When router 2 will receive it, it will check destination 2.2.2.1, right? This is my IP address. Let me check the further information. It will remove this header and after that it will check this destination. This destination is 192.168.10.1. Then router will forward it to server. So we need to add this extra header. And this is, guys, nothing but the VPN, right? So what we will do, we will create one tunnel interface over here and we will define tunnel source IP address 1.1.1.1 and tunnel destination IP address 2.2.2.1. On router number 2 also tunnel source 2.2.2.1 and tunnel destination 1.1.1.1, right? And then you can configure one route here, a static route. like for 192.168.10.0 exit interface is tunnel interface. Whenever exit interface will be tunnel interface, router will add one extra header. In that extra header, source IP will be the tunnel source, destination IP will be the tunnel destination. Whenever exit interface is tunnel interface, then router will add one extra header, that is GRE header. In the GRE header, source will be the source IP address of tunnel, destination IP will be the destination IP address of tunnel. So on router number 1, I can say interface tunnel 1, source IP 1.1.1, destination IP 2.2.2.1. It's very simple. Here I am going to add one more PC. This PC IP is 192.168.10.2/24, 192.168.10.254. Now can PC access internet? Yes, because dynamic NAT is already running on router number 2. So ping 8.8.8.8. Ping is working. Can guys this PC1 ping to this PC, this PPC? No. To access this PC from PC1 from this network or from the internet, again you have to configure a static NAT. Now how to create VPN between router 1 and router 2? So see on router number 1, config T, I'm saying interface and then tunnel interface, right? Tunnel 1. So my tunnel is created, but tunnel is down. This interface is down. The reason, we didn't define the tunnel source and tunnel destination. So now I'm saying tunnel source. Tunnel source is 1.1.1.1, my public IP address. Then tunnel destination, remote public IP address 2.2.2.1. And guys, even I can configure one IP address on this tunnel interface. So now you can see tunnel is up, right? And on the tunnel interface, I am defining IP. Let's say what IP? 172.16.1.1, 255.255.255.252. In the same way, I can create one tunnel interface on router number 2 also. Interface tunnel 1 and the IP address 172.116.1.2, 255.255.255.252, and then tunnel source. Tunnel source, I can say fast Ethernet 0/0 also like this, and then tunnel destination. Tunnel destination is 1.1.1.1. Now you can see tunnel is up, and guys, through tunnel can I communicate? Can router 1 and router 2 ping through tunnel 172.16.1.2, which is the IP address of router 2? See, ping is working. So how ping is working? So IP route. When I am pinging 172.16.1.1, see, route is there in the routing table, and exit interface is what? Tunnel interface. So if exit interface is tunnel interface, it will add GRE header. Actual message is source 172.16.1.1, destination 172.16.1.2, right? Then router 1 is going to check their routing table. In the routing table, route is available and exit interface is tunnel interface. So exit interface is, if exit interface is tunnel interface, then it will add GRE header, generic routing encapsulation, right? And in the GRE header, it will add extra source, extra destination. Source IP will be the IP address of tunnel, source IP address of tunnel, which is 1.1.1.1. Destination 2.2.2.1, tunnel destination, and then it will forward to router, internet router. And internet router will forward traffic on the basis of this header, right? So to verify it, you can capture any link. Let me capture f0/0. Right, and see, I am going to ping again from router 1. I'm pinging this IP address, and see, guys, this there is one extra header, right? GRE and then extra header. Actual information is here. Source IP 172.16.1.1, destination 172.16.1.2. Then GRE, and after that extra header. In the extra header, source is the tunnel source IP address. Tunnel destination is tunnel destination IP address, right? So these two IP addresses are public IP addresses which are reachable on internet, means internet router can forward the traffic. And now on this tunnel interface, I can configure the route, like a static route, IP route 192.168.10.0 and the next exit interface is tunnel 1 interface. So now when PC1 will ping to 192.168.10.1, will router use default route? No, because this time a specific route is available in the routing table. Yes, a specific route is there, right? And exit interface is tunnel 1. So if exit interface is tunnel 1, then it will add extra header. And in the extra header, source will be public, destination will be also public. On the router number 2, on the router 2, I can configure route for 10 network, 10.1.10.1.1.0, 255.255.255.0, and exit interface is tunnel 1. Now these two private side can communicate with each other, right? Like from PC1, I can ping to this PC. See this PC, ping 10.1.1.1. Ping is working. This is how two private side can communicate with each other through public network, our public network. Right, guys? See, just open any packet. The actual source is 192.168.10.2. Actual destination is 10.1.1.1, right? But in the extra header, source is public, destination is also public. Done, guys. And the protocol number of GRE is 47. GRE is a layer 3 protocol which works on tunnel interface. So when your router will receive the traffic, right, first it will open the outer header, it will check the destination, then it will check the protocol field. In the protocol field, value is 47, that means it is a GRE encapsulation. It will remove the header and then it will check the actual information. Yeah. Sorry. No, no, I have configured one subnet on the tunnel interface. See what I did. I create one virtual link between router 1 and router 2. How? With the help of public IP address. With the help of my public IP address and remote public IP address, because both are reachable, right? So with the help of those public IP address, I have created one virtual link, and on that virtual link, I have defined IP address. So both IP addresses are reachable with the help of public. On the tunnel, I have configured private IP. Now I can here configure routing protocol as well. I can configure the static route as well, right? Yes, yes, correct. If you will not configure the IP over here, then there is no identity of the tunnel interface, right? Anything else, guys? Before GRE? Both router will exchange GRE message. Yeah, GRE the protocol message. To make communication between two private network over public network, right? Correct, right, right. No, no, bro, that is different thing. See, my requirement over here is, let's say I have, my company has two branch, one in India and one in US. So how these two companies are going to communicate with each other? Both are connected through internet. So how these two companies are going to communicate with each other? Because this is the private, and this is public, right? So by default, two private side cannot communicate with each other over public network. So that's why here I am creating VPN. Through this virtual private network, I am going to exchange my private data. Hmm? Is speed means it is still using this physical link only, bro, to forward the traffic. There is no any other link to forward the traffic. It will forward traffic from the actual bandwidth only, right? From the physical link only. But here I am adding extra header. And actually you can see we are encapsulating our private packet in one extra header. And see, this is not secure. So here we cannot forward the traffic directly. Here I have to configure IPsec to secure it. Internet is not secure. So your private data is flowing through public network. Anyone can capture it. So we are going to now secure the VPN, right? So why we come up with VPN? Because by default, two private sites cannot communicate over public network, because public network don't have, guys, routes for the private IP addresses. Yes, yes, go ahead. Yes, you can configure the GRE. If I have guys one more side here, then what will happen? Here I can configure one GRE. Here I can configure one GRE. Here I can configure one GRE. Different IP address. For each tunnel we will using different subnet. Difference between GRE and IPsec. IPsec is used to secure the GRE. GRE is a point to point connection, you can say point to point connection. But guys, in this scenario, let's suppose here I have 100 branch. This is, let's say, headquarter, then I have 100 branches. Then it will be very complicated, right, to configure GRE. Because GRE is point to point, we can configure the tunnel between headquarter and branch 1, headquarter and branch 2, branch 1 and branch 2. So between three sites you can see I need three GRE, three connection, right? On each we will be using one separate subnet. So that's why we come up with DMVPN, right? DMVPN. So is VPN clear? Then we can move to DMVPN. So don't worry how we are going to connect more than two sites. Let's understand what if we have two sides only. Understand first point to point. Correct, correct, correct. Hmm, hmm. MPLS is different thing, brother. Open standard. Open. I already told you, brother. MPLS is one type of forwarding, like how router is forwarding the packet. Now, with the help of routing table, they are checking routing table, right? So MPLS is one another types of forwarding, like how switch is forwarding the data, how router is forwarding the data by checking routing table. MPLS have their own mechanism to forward the data. Done, guys? No any more question? So when router will add GRE header, whenever exit interface is tunnel interface. So if this PC will ping to 8.8.8, when this PC will ping to 8.8.8, will router add GRE header? No, because 8.8.8 will match in default route, right? And for the default route, exit interface is physical interface, right? So it will not add the GRE header. But when I am pinging to 192.168.10.1, is this time what will happen? Destination will match in static route and exit interface is tunnel interface, not physical interface. So it will add the GRE header. Done. So interviewer can ask you these types of questions like the default route is also running there, right? And some routes are there with the tunnel interface. So when router is going to add the GRE header, and when it will not add the GRE header, and it will forward traffic to internet directly. So if the exit interface is tunnel interface, then only router will add the header, GRE header. Yes. Next class we'll see dynamic multi-point virtual private network, DM VPN. What if we have more than two sites? Okay, if we have two sites, guys, then we can configure the GRE and it will work fine. Now to secure the GRE, as I told you, we have IPsec, so we can configure the IPsec to secure the tunnel, right? Like in the capturing, you are able to see that all data on the link, right? But after the IPsec, you will see your data is encrypted. It will encrypt the data before forwarding from tunnel interface. Again, IPsec will only encrypt the data on tunnel interface, right? We'll configure IPsec for tunnel interface only. So the traffic which will go to internet like 8.8.8, IPsec will not touch that traffic. It will touch only the traffic on tunnel interface. Clear, boss? What hurts?